Cool. Okay, welcome guys. Welcome to this session, Designing a VDI the VCDX way. My name is Johan from Amersfoort. I am an EUC architect working for ITQ Consultancy based in the Netherlands and in Belgium. And I blog, I tweet, I recently released a book specific about this session. Well, not about this session, but the contents of this session. So how to design a VDI based on modern standards and through the whole VCDX design methodology. If you guys would like to download the slide deck, the link to the slide deck is right over there, where you can find basically the whole overview of this slide. What I want to do in this session is cover the different phases within the design project, and at the end, if there's time, I want to cover some of the design considerations you might come across. So stuff like GPUs or no GPUs, HCI or traditional storage, basically stuff like that. So why should you basically create a design for a VDI? Imagine, oh, that's why. Imagine you want to build a dream house. If you prepare well for the dream house, or well, basically if you don't prepare, so you don't create a design, you basically, you buy some ground, you start building without any proper plan. You don't figure out if it's a sand or a muddy ground, or what kind of soil you have, how the sunshine is constantly, or the sun is constantly shining on your house, or depending on the type of weather, you don't choose like thick windows or thin windows. You could basically end up with a situation like this. Build a dream house, but end up with a piece of crap. And that's basically, you know, because sand ground or muddy ground doesn't allow you to use the same kind of structure or base structure, and could crack up in case something goes wrong. So it's an example of why you should think about what you want to do, work something out, go through a design methodology, and start building as soon as you've figured everything out. So there's the design approach, and I'll go through each of the steps. So I think that the most important part of a design is create a goal. What would you like to achieve with a design? Is it a big house or a small house? You know, if your family has, I don't know, 10 people, and you're building a tiny house, you probably won't fit in that house. The same with a VDI design. If you want to build a VDI design primarily for graphical designers, for instance, but you end up with a design that doesn't allow you to have those powerful single-threaded applications, you'll end up with a bad user experience. So define those goals. What would you like to achieve? Increase your security, have a graphically intense, powered platform, achieve a bigger uptime, stuff like that. Gather those requirements. So if the customer tells you that they would like to have an uptime, a big uptime, like they want to achieve high availability, define high availability. If the customer, for instance, wants you to build an environment with 100% uptime, well, those who have worked in IT probably know that that's not going to happen. It's quite unachievable. But a VDI with 2 nines of availability has a different kind of approach than a VDI with 4 nines of availability. That's something you need to take into account. Define constraints. So if the customer would like to reuse current hardware, so I don't know, HP Blade infrastructure, and those hosts only have 2 disk slots, you're probably not gonna design it for an all-flash vSAN containing multiple disks. So those constraints you need to take into account as well. Identify risks. So if the customer would like to have, or you would like to have, an availability of 4 nines, but you only have 100 Mbit between 2 data centers, might be a challenge. So identify those risks. Assess the current workplace. Maybe if you Compare this to designing for a data center. Assessing the current workplace is something that stands out for a VDI, because you need to know your end users. What are they expecting? How do they do their work? If you design a VDI that's not accessible from the internet, but all of your users would like to work from home, it might be a challenge. So assess the current workplace and know what kind of applications you will would be working with. Single-threaded, multi-threaded, maybe graphically intense applications. It's very important. Define use cases. So I already mentioned those designers, but we know that that a lot of different use cases might exist. Users that would like to work on a tablet, for instance, or users that need those GPUs or would like to work from home or not, need multi-factor authentication because of a high security risk, stuff like that. After we have all those bits of information, it's time to start to create a conceptual design. And I'll show some more in detail about that on some next slides. The same for a logical design. So we start with the concept. The concept will, like users need to work from home, will turn out in a logical design in which we define components that will allow the user to work from home. In a physical design, we'll decide the number of the components and, for instance, the sizing. Very important is to validate with a proof of concept. So prior to a project, we could design something based on an assessment details that we have. So maybe you have 500 applications. We know that they're graphically intense, but it's quite hard to define a sizing and buy hardware for it, because density, testing the number of users that you could land on a single host, it's unpredictable, to be honest. So that's why you need to do a proof of concept prior to going into production. And finally, build a production environment. Now we're going to dive somewhat deeper into the different steps. So first, the goals, the requirements, constraints, and risks. What I find really important, and I recommend you guys reading this book, is start with why. So I already mentioned the goals within a project. If your organization or your customer doesn't really know why they want to build a VDI, it's probably going to end up with something that's unmanageable, something that's far too expensive, because you need to create a business case prior to everything you do in order to know if you're going to succeed. So gather those requirements, those constraints. Basically, constraint is also a requirement, but it's something that limits you in your choices. So it is something you have to work with, but the design choices are limited due to that constraint. Assumptions basically are something you would like to avoid, but not always can avoid. So, for instance, if the customer has a concurrency number, something you could measure up front, but you don't really know if you're going to build a greenfield VDI environment if users are actually working concurrent for a certain number. You don't know. You might don't know what the boot times, the boot storms could be for a VDI. So it's good to always mention an assumption. I assume that we have over 2,200 users that might be working concurrent, and by naming that assumption and define a risk that goes with that assumption, you'll be safe in your design. Important, every assumption comes with a risk. And risks will be mitigated by using design decisions. So if the assumption could be that we have 2,200 concurrent users, the risk might be that if there are more, we'll have a challenge, and a design decision could be that we're building blocks to scale up the design based on a single host that could contain like 60 users. Next phase, so assess the current workplace. I already mentioned those users, but it's important to run the technical assessment as well. There are a couple of tools to do that. So my preferred tool is Liquidware Stratosphere because it deploys very easy and it gives you insights within maybe a couple hours. But Lakeside Systrack is a fine tool too. Important, run the tool for at least 5 weeks. And the reason for that is that in some cases, like financial use cases, users run certain queries just once a month to gather invoicing information or other information, and you need to know what those peaks are within that period of time. Talk with the business about their expectations, and that's basically defining those requirements. A bit of the same conversation, but you know, I've worked on a project in the Middle East, and the average log-on time at the customer was 7 minutes. So our goal of the project was to decrease the log-on time to something. We managed to decrease the log-on time to 1.5 minutes, and the customer was happy. All end users within the customer were happy because they didn't have to go to the coffee machine after logging on, coming back and were presented with a desktop. If I'll present or if I'll design a VDI with those same numbers for instance, a hospital, I'm pretty sure the customer will fire us as an architect. So talk with the business about their expectations, really important. And users. And if you have all of those, if you finalized all of those interviews, plot them into use cases we also call personas. Know what type of use cases will work on that VDI. And I'm mentioning it here, but it usually will come up with a sizing estimation later in the project. But what we see is that in most cases, there isn't enough time to design and talk to users for, let's say, a couple of months. Customers would like to put time on it, and time could be a constraint on a project. So creating a sizing estimation based on the assessed data you have here might be important to do that in the assessment phase as well. So the conceptual design. As you can see on the conceptual design, it contains high-level information. That's basically it. You see something with data centers, with user data, and you see that we have a virtual infrastructure beneath it. It basically describes what the concept is of the design, not how we're going to do it, but what we're going to do. It doesn't contain any details of solutions, because in a hypothetical greenfield project where you didn't buy any license or hardware yet, you might define here that you could either run with an HCI that could be based on vSAN, but it could also be based on something else. And you don't want to make any decisions based on what you know here. You would like to do that later in the design. Logical design. This is where you make those decisions. So it contains mid-level details. What you can see here is that we still have those hosts, so the virtual infrastructure, but we also have something specified about we need a vCenter and we need something like a connection server. There are multiple connection servers drawn here, but that's basically because we also need a load balancer. I need to define in that logical design why we need a load balancer. But it doesn't contain anything about the number of connection servers. That could either be 7 per site or 2. So it basically describes what the functionality will be in the design. And again, it contains details of the solution, not about stuff like numbers. In the physical design, we do describe stuff like numbers. So in this case, I just mentioned load balancing. What you can see, there's a low, it's low level based. So every bit of detail that the engineer or the person that's going to deploy stuff needs to know that bit of information in order to create a successful deployment. So it describes how the functionality will be implemented in the design. In this case, you can see 2 connection servers. You see in this case, an NSX load balancer. If I would use an F5, for instance, you would define it there with either GTM or LTM, stuff like that. And in this case, you see I use root 53 instead of a GTM by F5. So it includes all the details of the solution, including numbers of components, etc. So now we have a design, basically. Next step is to validate if everything we did was good. Important, run a pilot or a proof of concept to show off to the customer that the thing that you thought in theory will work in a practical way as well. Validate your sizing. So you might already have heard that Windows 10 has an impact in terms of graphical acceleration, but the thing we don't know for sure is what the impact will be. Could basically mean that you don't need a GPU. It could mean that you need a lot of GPUs. And the only way to find out how many or how, if and how many you need is to do a sizing test. There are tools to do a benchmark test at scale, like login VSI, but they don't give an actual user behavior, because user behavior is unpredictable. And the thing that a benchmarking tool does is create predictable behavior. So run with a couple of users on a new proof of concept or pilot environment and see how they expect, what their experience is. Again, talk with those users. So synthetic testing, like I just called it, it's good, but it doesn't give those 100% real life scenarios. What we do differently based on that pilot is to educate users and important advocates within your company, because people don't like change. And moving towards a VDI, moving towards maybe another OS in a VDI, is something that comes with a lot of changes. And what we do actually is to run roadshows within a company using that proof of concept to show off the new architecture, the new functionality, and get the user already familiar of how that new way of signing in, for instance, is, or how that multi-factor authentication will work. So definitely something you should consider. What I'd like to do now is go through a couple of design considerations that I describe in the book as well. Depending on the number of the amount of time that we have, we could cover them all, or just a couple of them. So who is familiar with LTSC versus semi-annual channel? So long-term service channel versus semi-annual. So who you guys are already working with VDIs, virtual desktops? And who deployed based on LTSC? Just one. Okay, two. There isn't a good or a bad here, but it comes with some additional constraints. So choosing for LTSC would mean that you get your annual security updates, but you don't get extra security features. And what we have seen in the last couple of years is that Microsoft is also releasing those specific security features that your users might benefit from. What we also have seen is that if you look at OneDrive, or well, specifically OneDrive, when Windows 10 1709 came out, there was a OneDrive Cloud Sync option, an on-demand sync, that actually let you synchronize OneDrive. So the user has OneDrive in its Explorer, like a My Documents, but nothing is synced yet. So he could see a document, but the document is somewhere in the cloud. If you use that feature, you could actually use non-persistent VDI with OneDrive, because no files will be saved on the desktop unless the user will edit the file. If the user has edited the file will immediately be synchronized with the cloud again, and you could sign out. A feature like this is released in the semi-annual channel with every update or every new version of Windows 10 that comes out, so that might be a consideration. If you would like to use new functionality, go for SAC. If your users are, if you have specific requirements that force you in using LTSC, go for that option. The book covers many of those considerations. What's important for Windows 10 in general is use automation to build your base images, and instead of upgrading those base images, create a new base image with every new version of Windows 10 that's released. If you are constantly upgrading your current base images, it'll mean that a lot of overhead, a lot of garbage basically, is still saved in your base images, and it'll cost you disk space. With every clone that's being created, that junk comes along with you. So rebuilding that base image with every update is one of the things that we definitely would like to advise. GPUs or no GPUs? And are there alternatives? So who is working with GPUs at this moment? And who did that because of Windows 10? Oh, not that much. That's good. So it is a it's not true that Windows 10 will require GPU to work. If there's no GPU in the system, Windows 10 will emulate your graphical workloads to your CPU and your physical RAM, which might work perfectly. Actually, the internal VDI environment that VMware uses, I don't work for VMware, but I've played around with it, runs a couple of thousand users without GPUs, and it works pretty smooth. But it's all about expectations. If a user would like to run video within that virtual desktop on 60 frames a second with a 4K screen, I can guarantee you that it might work on a single desktop, but as soon as you start to increase the number of desktops on a single host, your user experience will drop. That's a fact. So it's all about expectation. If your current company or your current customer only has single monitor desktops based on Windows 10, but tuned with the optimization tool, the Windows 10, the OS optimization tool, you're probably going to be fine. The graphical intensity will increase as soon as you add another display. Make it 4K. Increase the number of frames. Use OpenGL, WebGL applications. So if you take Google Earth, for instance, or any other map application, web application there is, it's all based on WebGL. And the problem with WebGL is that it expects a GPU to be in your system. If it's not there, your CPU and your RAM will be overutilized, and that will probably cause a challenge. Are there alternatives? I think there are, and there are a couple of them that we could use. So for instance, there is URL redirection in the Horizon client for Windows and Mac. There is media redirection that works pretty much the same in the same clients. And what it does, if you click on a YouTube video, the video would be displayed on your local endpoint device instead of being displayed in the Horizon client. And that's a perfect option if you have specific video requirements. Skype for Business, same thing. You don't have to run Skype for Business inside your virtual desktop being powered by GPU. You could perfectly offload Skype for Business using the Skype for Business plugin in the Horizon client. And what will happen is that a peer-to-peer connection to the endpoints is created without the virtual desktop being utilized for that. So those are perfect examples of what you could do without a GPU. In all cases, it's basically it's important to test out in a pilot if that situation would work for you or not. Persistent clones versus persistent user experience. So is everyone who's not familiar with persistent versus non-persistent? Okay, so the thing you would like to achieve is to create a clone, and as soon as a user signs out, that clone is decommissioned. So that's basically how instant clones work. An instant clone is basically a snapshot in memory of a host. Everything that's committed to the desktop is gone as soon as the user signs out. There are certain tools like User Environment Manager, and there are a couple of those tools that allow you to commit those changes to a other location, to a profile basically. And as soon as the user signs out, those changes are committed. The next time a user signs in, he'll get a fresh new desktop, and those settings are injected again. So that's what we call a persistent user experience based on a non-persistent desktop. Cool. I think the most important part here, especially from a management perspective, is to have as much non-persistent desktops as possible, because committing a change to a non-persistent desktop from a management perspective, so for instance, do an application update or patch your OS for some reason, is done by committing it to your base image. And as soon as users start to sign in for a new desktop, they'll automatically get that change. So you don't have to patch all those individual desktops. So go for persistent for non-persistent clones as much as possible, and give the user the idea that he is working on a persistent clone, while the technology within, in this case, Horizon Enterprise, will cause you to use non-persistent with those persistent settings. So I think we need to finalize. Again, you could download everything from the website. This contains some more details about the book, which I don't want to explain now, but do you guys have any questions about VDI in general, the VCDX methodology, any of the considerations? Sorry, the link. I think the link will be shared tonight at the vBrownBag YouTube channel. So if you look at the video, the link will be in there, as well as in the notes. Cool. Okay. Thank you, guys, and enjoy the rest of your show.
Give me number 1 instead. Hey guys, our presenter Dermot, who was going to do the vSAN behind the scenes presentation, has not arrived and should have been here 10 minutes ago, so I don't believe we will have a session. You're welcome to hope that he turns up, but I have no expectation that there will be this session. The next session will be here in about 30 minutes, and I cannot remember its title, but you probably didn't book that. My apologies for not having a tech talk for you right now.
I'm talking, yeah.